Hello, good day. So for this video, I'll be presenting and introducing to you what is inferential statistics. Now, inferential statistics is a higher level of statistics and also another branch of statistics. So when we talk about descriptive statistics, it's basically the foundation or basic statistics, no? It deals with the mean, median, mode. But unlike with inferential statistics, we're attempting to prove something. More likely that the thing that we attempt to prove would now be hypothesis or our assumptions or our predictions. So what makes inferential statistics different from descriptive? So let me define what is inferential statistics. So inferential statistics, it attempts to measure or measuring the few, sample, and generalizing the many. So it's like statistics, the basic definition of statistics. But what it makes it distinguishable from the definition of statistics, inferential statistics attempts to make predictions, inferences, or it infer in a population. The term infer would now be will now brings us brought or bring us on, di naman ang English major, to your hypothesis testing. We now attempt to prove something. So it's more likely testing, no? Now, before going to your hypothesis testing, here are the following areas under inferential statistics. We just look to the concepts and and principles that we use in social science research. Kaya hindi natin pag-aaralan lahat, no? At na-insert na yan, no? Actually, dun sa mga succeeding discussions natin or video tutorials, no? So we have hypothesis testing. So I'll be discussing this one later. Your normal distribution. Normal distribution, I already introduced this one. I introduced you to the distribution curve. Although medyo pag-aaralan natin siya lalo sa inferential statistics. Your t-distribution as well, lalo na sa t-test natin. Your confidence interval. I already introduced you to confidence interval dun sa mga level of significance natin, no? Or sa level of confidence natin. 95%, 0.05. Regression analysis, I provided insights already sa correlation and regression. So medyo satisfied na tayo dito. We do not look into the high levels. Central limit theorem, your mean comparison. So we now compare means as well. Then your binomial testing. So there are some principles, concepts na pag-aaralan natin. Only some lang naman, no? However, for this video, inferential statistics would be incomplete without understanding what is hypothesis testing. Now, when we do research, we already have we must craft hypothesis, our assumptions about the study that we'll be conducting, no? So we will be conducting. So from that assumptions, we now draw if we are correct or whether we are incorrect, no? So yan yung importance ng hypothesis testing. However, in quantitative analysis, there's a more organized way on how we now craft or create our hypothesis. Unlike sa qualitative, we could just create our own. However, when you do quantitative researches, may organized way dapat yan, no? Okay. When will we use hypothesis testing sa inferential statistics? Or paano? So there are two types. We have the null hypothesis, which stands for HO. Then we have your alternative hypothesis, which stands for HA. Or rather, H sub O and H sub A. Although I prefer HO, HA. Yun na lang pa mas mabilis. Okay. When we craft these two, may commonalities yan, eh. So when we talk about null hypothesis, we have a hypothesis that attempts to prove that there is no or there are no significant differences or no significant relationship. So now, pag null, HO, more likely negative statement yan. No. So looking into the diagram, diagram pa ito, basta dito sa example na binigay ko, for instance, when we do causality, your independent variable, walang kinalaman sa dependent variable. Or in correlation, walang relationship yan. Dalawang yan, no? Or in comparison, mean comparison, walang difference. Males, for instance, um, for example, sa null hypothesis, males, we have that null hypothesis that males and females are equal in terms of IQ. Example lang naman na null hypothesis yan. Now, unlike with alternative hypothesis, affirmative statement yan. There is a significant difference or relationship. You're trying to prove that there is an existence of a difference or relationship. So therefore, para siyang ganito, no? So may cause yung IV at DV natin, yung independent at dependent variable natin, or may relationship yung dalawang variables natin. Now, to give an example, stated example na lang, although I will provide I will just provide examples of null and alternative hypothesis sa caption. Although to give an example, in terms of gender na lang, sabi na natin in terms of physical endurance. Kaya physical endurance, no. Dito, there is no difference in terms of physical endurance among males and females. So there is no. Pag dito, there is a significant difference of physical endurance in terms of males and females. So ganun yung ano natin, no, pag-graph natin ng hypothesis testing. But just to give you other information, I'll just provide examples sa ating captions. Okay, another thing para magets natin yung hypothesis testing natin, let's look into the distribution curve. Okay, in your distribution curve, ganito yung how your null and alternative hypothesis would now take in place. Pero unahan ko na kayo, mas madali siyang maintindihan pag pumupunta na tayo sa actual na computation. But just to provide you the principle, kunyari ganito, no, may use a two-tailed distribution curve, lalo na sa t-test, no. Okay, I've been discussing this one into since the beginning. So ganito siya, no. Okay. In your confidence interval, the widely suggested is 95% sa social sciences, Then we have a margin of error which is now 0.05. Now sa two-tail margin of error or your alpha, dahil two-tail yan, ihahati natin yung 0.05. So magiging 0.25, 0.25. Now ang tawag natin dito sa shaded na parts na ito is now your critical value. Critical value at nandito ngayon yung alternative difference natin, ay alternative hypothesis natin. Now, within the curve, kung saan nako-concentrate yung numbers natin, yung population mean natin, for instance, ito yung 95%. Now, going back with your hypothesis testing, pag pumasok yung p-value natin dito, automatically, pumasok siya sa level of confidence. This is now where we now accept your HO, yung null hypothesis natin. Now, to give you a clue, paano yan? You want to compare two means, for instance, males and females. Yung male nandito, yung females nandito. Ano ibig sabihin yan? Magkakalapit sila, and in the same time, within sila ng HO sila. Kaya kung magkakalapit yan, walang difference. Walang difference, they are equal. Now, for instance, yung p-value natin ay pumasok dito sa shaded part, sa critical value natin. We now accept HA, which is now may existence ng difference. So, existence ng difference, hindi sila equal. So, an example again, sa gender kunyari, nandito yung females, nandito yung males, hiwalay na yung ano nila, yung p-values nila. So, automatically, may difference. So, going back kunyari sa dependent variable na example natin na physical endurance. Nandito yung females at nandito yung males. Malala yung values at hindi well concentrated yung values, automatically may difference yan. So, HA and HO. Although, mas madali siyang magets when we already go to your computations, no? Although, ang mahalaga naman dito is yung principles, Kaya when you try to incite or do your research already, you will be having your Excel, SPSS. At least kahit paano, alam naman na natin to. Although, one more example, hindi lang kasi two-tail yung ginagamit natin. Paano kung one-tail or one-skewed lang yung ating distribution curve, no? Hindi na natin hahatiin yung 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 alpha ano natin, yung margin of error natin. So more likely ganito siya. Although there's a separate discussion kung saan natin gagamitin yung two tail and one tail. So ganun din, no? Yung shaded part is your critical values. There's a separate discussion on this one kung saan natin gagamitin. Now, to add in this video tutorial, although at sasabihin ko na mas maaga, this is more relevant in medicine and in more relevant kasi madalas siyang ginagamit sa medicine and engineering subjects, no? So we have errors in decision making. However, relevant din sa atin, although not the computation part, although on how we now draw or craft our conclusions sa ating thesis, sa ating study, no? So kasi when we try to craft our conclusions, we must take note that that our hypothesis, our assumptions are still prone to errors. Okay, ano nga ba tong errors in decision making? Simply ganito lang yan, no? Errors in decision making, when we do hypothesis testing, our hypothesis testing are still prone to errors. We could not achieve a 99% or rather a 100% confidence level, no? That is impossible in sciences. We must now recognize the possibilities of errors when we draw conclusions. Or the other way around. In drawing conclusions, we recognize yung possibilities ng errors. Or other way around ulit, no? Just to emphasize. We recognize errors before we draw conclusions. It's a mutual principle, no? And when you recognize na may error, there is now the chance for the researcher to minimize yung errors natin. Kaya we do error analysis in statistics in order to minimize errors. I hope you get the point, no? Now, this is just for the sake of knowing things, no? There are two types of errors, type 1 then type 2. Okay. Now, paano to, no? Okay. You have a hypothesis and later you make a conclusion, but your type 1 error is you reject a true hypothesis. You're rejecting the truth. So this is quite logical din siya, no? Medyo part din siya ng logic. There's a separate discussion on this one on logic. Type 2 is that you accept a false hypothesis. You have accept a false statement, no? Kaya for instance, in jurisprudence, diba? Type 1 error is you convicted an innocent defendant. He's innocent yet pinakulong mo. A type 2 error is acquitting a criminal. So jackpot yung criminal natin, no? This is your alpha, this is your beta. So false positive, then false negative. Or for instance, in medicine, diba? In terms of medicine, you stated that a person is pregnant when in fact hindi siya pregnant. That is type 1. Or type 2 would now be you have declared that person is not pregnant pero pregnant pala siya, no? So ganun yung type 1 and type 2. Now, ano yung principle niya? Although we not look into the technicalities, no? Ano yung principle niya when we attempt to draw conclusions? We must look, or rather we must prepare ourselves, or simply going back dito, i-recognize lang natin yung possibility of errors natin. So that's it, no?